Hey Thinksters, what's up? It's Chris from Thinkster.com, and today I want to answer the question how to get elements with specific indices from a Python list. And so say you have a Python list of 8 elements like this, and the first element having index 0, the last element having index 7. How can you access like specific elements from this list? And this is different from slicing, which you may know, for example, where you want to access a subsequence of these values. You can even have like a step size of 2 or so with slicing to access only like a regular part of the Python list. But what if it is highly irregular? What if you just want to have like access some arbitrary indices from a very large list? Like even you may want to index some elements twice, so some elements at a certain position twice or so. Okay, so in this example we have like 8 elements. We want to access 3 elements with indices 0, 2 and 6, and we want to create a new list that contains the elements at those positions. How do we do this in Python? Actually there are 5 different ways I have identified, and in today's video I will go quickly over each of them and identifying the specific and unique advantages of each of the method, so that you know which method to take in which circumstance. Because a great coder will always take the method that suits the problem best. Okay, so the first method, and I have placed it as the first method, is because it's, in my opinion, the most Pythonic way. So if you just want to fix this problem, then take this method. It doesn't require any external library or so. Let's call it method 1. It is based on list comprehension. Okay, so we create a variable out, and if you print out, we expect that we have a list with the elements A, C, and G, which are the elements at position 0, 2, and 6. Okay, so we use list comprehension. List comprehension consists of an expression statement and a context statement. The expression statement can be any function on a given value that you define in the context. So for example, you want to add, so you use the the LST list to access the element at position I, and now you need to define I. So what values will the variable I take on? And here you can define any context. You can use a for loop, like for I in indices. Okay, so you have stored the indices you want to access in your variable, in the variable indices. So now you just simply iterate over them, and I will take the values 0, 2 and 6 subsequently, and then you simply use simple indexing, list indexing, to get the element at this position. And now you place all the elements inside your list. So this is the first method. It's straightforward. Many coders even don't see it if they just start out with the Python code, but it's a very simple method, and it's also very efficient. List comprehension is efficient. It is like it is built in Python, so it's implemented in C++. So with this C Python implementation backend, so it's like very efficient. You don't have to import an external library. It's short, concise, and readable. So you should like prefer this method, in my opinion. Okay, the second method is if you have this problem oftentimes in your code, then you would have to write this whole thing again and again. So it takes a lot of space, takes a lot of characters to write it. In this case, I would say that it's better to import the numpy library once and use the numpy library. So first you need to convert the list to a numpy array. You can use the np array list method. You simply pass the list into the numpy array function, and now you have a numpy array. And numpy arrays are more powerful than Python lists in a sense, because they allow you to access arbitrary indices. So you can simply pass your sequence of indices. This is the list, yeah. So indices is a list of indices and indices, and you can simply pass this list into the accessing scheme. So this is not possible for default Python list, but as A is a numpy array, it is possible. So you can really put any sequence you want into your indexing scheme within the square bracket notation, and this retrieves all the values you want. In our case, the values with indices 0, 2 and 6. Okay, so if we run this, we get two times the same result, A, C, and G. The second time you see it's a numpy array. You can see the differences here, that there's no comma. This indicates that it is a numpy array. So because Python lists are always visualized in the shell as having this one comma notation. Okay, so as a delimiter between the list elements. Okay, so this is the second method. It's a numpy method. If you need to do this repeatedly, oftentimes you should use numpy. Otherwise, you can simply go for the first method. Now I want to show you the third method. Is used on can be sometimes, this is more for educational purposes, because sometimes you will see the item getter function. So you can import the item getter function from the operator module, and now you again create a variable out. You convert the result of calling the item getter function to a list. Okay, so now let's first call the item getter and pass the values in the variable indices. Okay, so you have the indices 0, 2, and 6, and you unpack these values using this asterisk prefix notation into the variable item get into the method item function item getter. Sorry. Okay, and this creates a new function that requires one argument. So you pass one argument into this new function. It returns a function object. So the item getter function returns a new function object. And this function object, of course, you can call it. So you can again use this opening and closing parentheses notation and pass the argument of this new function. And what does this function do? It takes an iterable as input, for example, our list, and returns the elements that are at the positions you passed here when creating the function. Yeah, so in here we passed 3 positions like 0, 2, and 6. You pass them into the item getter function. The item getter function then it uses this generator pattern. It creates a new function object, returns the function object, and now you can call this function object by passing the list. And then it will just return a tuple of the values at positions 0, 2, and 6. Because you passed them here in this part, and but now it's a tuple, so you need to convert it to a list, and that's it. Okay, so it's an effective way, and it doesn't harm to have seen this, because many coders will actually use this item getter function. It's quite functional, quite Pythonic, I would say. Okay, so you see all of them produce the same output. Let's go into the fourth method. I just wanted to add this fourth method. It's kind of trivial, but often it's like the naive approaches are, many times they are quite useful, and they are quite even the best approach to a problem. So for example, if you just want to access 3 elements from a given list with 3 specific indices, so then there's maybe no need to write a small algorithm like this in list comprehension to extract this element. You can simply directly go for these elements. It takes the same amount of space, you see. So our method 4, it takes even less number of characters than method 1. So in this case, it's fine to just create a list and put the elements into the list. Okay, so you use simple indexing to access the element. For 3 elements, this is fine. If you have, of course, if you want to access 50 elements, then you should use list comprehension, and maybe you have stored the 50 elements in your indices variable. Then, of course, I mean, it now becomes really tedious to write all the program code yourself. But I mean, if you can directly do it, then the brute force approach, it's actually very efficient, and it's readable also, and it can be very short. It depends on your concrete problem at hand. Good. Then just for comprehensibility, I want to give a method that shows how coders coming from other programming languages think. So for example, if you are a Java or C++ coder, you come from those languages, then you may want to do something like this. You have a variable out, which is initially the empty list. Then you go over all indices, and then you append the element at position I in your list data type to your out variable, and you print everything to the shell. And this I mean is readable, kind of. It's also efficient because you use the append operation. So you work on an existing type, you just append one element at a time to an existing list object, which is kind of efficient, but still it's not very Pythonic. So this is just, if you see something like this and you know someone who isn't really very deeply into Python, so who isn't really a Python expert, has written this. Maybe he comes from another programming language, because you can write this in a single line of code with list comprehension. It's much more readable for at least for coders that are used to the Python list comprehension syntax. And all expert coders are used to the Python list comprehension syntax, so therefore an expert coder will always use list comprehension. But it also works, of course. You can do this, but then just know that everyone will immediately see that you are not an expert Python coder. Okay, but otherwise it's fine. It's also fine not to be an expert Python coder, not to write perfect code. It's better to write code that works, that solves a problem. This is always the number one criterion. So you should never be shy, for example, publishing your code and telling and showing the world that you are not an expert coder. This is not a problem. So you need to fail sometimes to learn and to improve over time. Okay, so thanks for listening to this video. If you are interested in like more NumPy stuff, then check out our book Coffee Break NumPy. And if you are interested in this basic Python things like list comprehension and so on, check out our book Coffee Break Python. I will have a link in the description below. If you are interested in like more advanced things you can do with Python, then check out our book Coffee Break Python Mastery Workout. It contains 50 like really hard Python puzzles that will improve your expert skill level in Python. Okay, so thanks for listening to this video and see you in the next video. Bye.